If we look closely at this graph, we notice that it's not traveling with uniform motion. It does not have a uniform velocity. We have used this example a number of times, and we know that this object is speeding up. It's accelerating. If we graph this data as velocity versus time, it would definitely not be horizontal, as it is accelerating. It is not traveling at uniform velocity. What would the velocity time graph for this data look like? Let's use this set of data to see if we can find out what the velocity time graph of an accelerating object would look like. We can see that the velocity is definitely changing based on the fact that it is displacing a greater amount for each time interval. When we plot the position time data points, we do not get a straight line. Rather, we get a smooth curve. This indicates the motion is not uniform. It is accelerating. We can see that for every set interval time, in this case 1 second intervals, the magnitude or the size of the displacement keeps increasing. For the first second, it displaces 6.25 meters. For the second, it displaces 18.75 meters, then 31.25 meters, 43.75 meters, and the last second, it displaces 56.250 meters to the right. It is displacing an increasing amount for each set time interval. It is speeding up. We cannot calculate velocity or instantaneous velocity because the velocity keeps changing. We can, however, calculate average velocity for each interval of 1 second. The average velocities can be calculated by using the formula delta v divided by delta t. For the first time interval, it calculates as 6.25 meters per second to the right, then 18.75, 31.25, 43.75, and finally 56.250 meters per second to the right. Now that we have the average velocity, we can use the formula average velocity equals velocity final plus velocity initial divided by 2 to calculate the instantaneous velocities at each whole second of time. I have skipped showing you the calculations and have provided you with the values. At time 0, the velocity or the instantaneous velocity is 0. At time 1, it's 12.5 meters per second to the right, then 25, 37.5, 50, and finally 62.5 meters per second to the right. When we plot these data points, we get a velocity time graph that is a straight line. This does not indicate uniform motion. This is not a position time graph. This is a velocity time graph, and this straight line indicates uniform acceleration.